Okay, welcome back to math class and welcome to 10-3. Yesterday we talked about what it means to simplify radical expressions. Today we're going to talk about what it means to perform operations with radical expressions. If you remember what an operation is, basically what I'm saying is how do we add and subtract radicals and how do we multiply radicals by other things. So we're going to kick it off with how to add and subtract. Now you guys remember if I had 3x plus 5x. Hopefully that's been so ingrained in you how to do it, you knew it right off the bat. That is 8x. But what I'm doing functionally there, 3x plus 5x, is I'm saying 3 plus 5x, right? 3x plus 5x equals 3 plus 5x equals 8x. With radicals, we do the same exact thing. If I had 3 times the square root of 2 plus 5 times the square root of 2, I do the same thing. It equals 3 plus 5 on the square root of 2, or 8 on the square root of 2. We can treat what's in the radical kind of like how we treat variables in equations in that way. And this only works if each of these numbers have the same radicand. You guys hopefully remember what radicand is. It's this number underneath the square root symbol. Kind of like how this only works if you have the same variable. You know, I couldn't do 3x plus 5y as easily. It's only because they're both x's. Here it's only because they are both the square root of 2. Yeah, so if I had even a longer one, 5 on the square root of 2 plus 7 on the square root of 2 minus 6 on the square root of 2. Longer, I still, since they're all in the square root of 2, I'm just going to take 5 plus 7 minus 6 on the square root of 2. 5 plus 7 is 12. 12 minus 6 is 6 on the square root of 2. And that's our answer. So you can, in some ways, treat it like it's a radical. But again, only if what's underneath the symbol is the same. So what happens? What happens if it's not exactly the same? Suppose I get one that says 4 on the square root of 54 plus 2 on the square root of 24. If they don't have the same radicand, if they don't have the same number underneath the radical, then what I'm going to do is I'm going to have to split this up using our simplifying techniques from yesterday until they have the same number underneath. So I'm going to split 54. Let's see, we can split 54 up into 9 times 6, and 9 is a perfect square, right? So I can split that into 4 times the square root of 9 times the square root of 6. And the square root of 9 is 3, so we get 4 times 3 on the square root of 6, or 12 on the square root of 6. Okay, so I've simplified 4 on the square root of 54 to 12 on the square root of 6. I'm going to write it over here so it's not confusing. I simplified this to this. Now I'm going to do the same thing for the second one. Simplify it. I have 2 on the square root of 24. Let's see, I know that we have 2 times the square root. Let's try, we can split 24 into 2 times 12, and we can split 12 into 2 times 6. Okay, so we have a 2 times 2, which will be a perfect square. So if I had 2 on the square root of 2 squared times the square root of 6, then I'm going to have 2 times 2 on the square root of 6, because these cancel each other out. 2 times 2 is 4. on the square root of 6, and that one is simplified. So 2 on the square root of 24 simplified to 4 on the square root of 6. I'm going to write this one up here. Now that they have the same number underneath the radical sign, I can do what I did with adding them. 12 plus 4 on the square root of 6. 12 plus 4 is 16. So this simplifies to 16 on the square root of 6. Okay, so that's adding and subtracting. Now we're going to talk about how to multiply whenever you have several things on the inside and outside of the radical. Again, I'm going to start with examples of doing it with just variables. Remember if I said 5x times 3x, what I'm saying there is I'm saying 5 times 3 times x, right? Our numbers we multiply by each other and our x's we multiply by each other. So we would ultimately get 15x squared when I multiply them. Adding, I added, but when I multiply, I multiply. It's the same again with radicals, where if I had 5 on the square root of x times 3 on the square root of x, I'm going to get 5 times 3 times the square root of x times the square root of x, or 15, 5 times 3 is 15, times the square root of x squared, and those two things cancel out, so I'm going to get 15x. Really similar to with the variables, again, as long as what's under the radical is the same, or it doesn't even have to be the same this time with multiplying. We just have to multiply them together, and you use your product property to simplify it past that. All right, let's try it with a little bit more complicated of an example. Suppose I had 3 on the square root of 2, and I'm multiplying that by 4 on the square root of 3 plus 6 on the square root of 2. Okay, now that looks a little bit complex, but we're going to treat it just like we have all of our other problems, as long as we keep like things together. So when I have something on the outside of a parentheses, I have to multiply it by both things inside the parentheses with our distributive property. So I'm going to take 3 on the square root of 2 times 4 on the square root of 3 plus 3 on the square root of 2 times this one. Basically, I'm just saying what's on the outside, I have to multiply by both things that are inside. So I'm going to take this, I'm going to do 3 times 4 times the square root of 2 times the square root of 3. Right, and then I'm going to add to that 3 times 6 times the square root of 2 times the square root of 2. Okay, now 3 times 4 is 12 times the square root of 2 on the square root of 3, which is going to give me the square root of 2 times 3, which is 6, plus 3 times 6, which is 18, times the square root of 2 squared, right? Or 12 on the square root of 6 plus 18 times 2. And 18 times 2, so we get 12 on the square root of 6 plus 36. And that's as simplified as we can make this one. So that's going to be our answer. Again, if you have any questions, feel free to let me know. But I think you guys can get this as long as you keep, Again, keep all of your signs straight, watch the grouping, make sure you multiply and divide before you add and subtract. Keep that order of operations steady in your mind. Probably write it at the top of your paper. Otherwise, you guys have this. You can do it.